All right, guys, good morning. We're looking at the assignment that I gave you guys yesterday, the free body diagram worksheet. I think there was like 19 assignments on, or 19 different problems that I wanted you to do. So a couple things first. You can see I have here on the board forces that are going to act up and down, which is if something is on the ground itself here, if something is on the ground, you're going to have the force normal pushing up against it and force of gravity pulling it down, right? Remember, push and pull, push and pull. Those equal and opposite reactions. That's the third rule, right? Equal and opposite reactions when we talk about forces. When something is in the air, you're going to have the force of gravity pulling it down. You're going to have air resistance going against it, unless it's just in free fall, where the problem will say disregard air resistance. So if that's the case, if something is in free fall, when you are drawing a free body diagram, the only force you need to include is gravity, and it's going down, okay? And then when you have up and down, the other one would be when you have something hanging. Usually it's tension. If it's just one thing, it would be tension. If it's got two strings that's holding something up, like a frame or something like that, then that would be, you'd have to draw two separate arrows and then break up the force that's hanging, the tension force. Say it's 10. If you have two arrows, you have to break it up to 5 and 5 because it's going to be equal on both of them. In terms of moving left to right, when you're pushing something or you have something that's applied, that's either going to be moving to the left or to the right or to the left. And then friction is going to be going against it. Again, so this is on the ground, left to right or right to left, okay? So if you have an applied force on something that's rolled across the ground, unless it says it's a frictionless, if it's something that's frictionless, then there's nothing there, okay? Especially if it doesn't have any applied motion. So let's look at number one. So the first scenario is a book is resting on a flat table. So it's resting on a flat table, which means there is no movement, which means there's no net force, because remember, what's the first law of forces? Okay, the first law is if something is in motion, it will stay in motion in a straight line until an unbalanced force acts upon it, which means that there would be a number for the force. If something is at rest, it stays at rest again until an unbalanced force acts upon it, which means the force would have some sort of numerical magnitude to it. Every time it's got a zero balance, that means it's going to continue to do whatever it's doing. So in this case, the book is resting, which means the forces need to cancel each other out. So the weight of the book, which is the force of gravity, is 15 newtons. Well, okay, you know that something is on something, or it's on the ground, or whatever, it's on a flat table. Something has to be pushing against it to counterbalance this 15 newtons. And that's going to be force normal, which is also 15 newtons. And because you know that the book is resting, your net force, 0 newtons. So that's number one. That's what your number one free body diagram should look like. Okay? You have the force normal pushing up at 15 newtons, the force of gravity pulling down at 15 newtons. The net force is 0. Why? Because the book is at rest. All right, let's look at number two. Number two. So number two is a box is pushed across a rough floor at a constant speed. So again, draw your box. It's on the floor, which means gravity's pulling it down. but it's being pushed across a rough floor. It's going left to right, or right to left, or no, left to right. It's moving to the right, okay? It's not moving up and down. So what does that tell you about the force of gravity and force normal? They have to be the same. You don't even need a value for it because you know that they're canceling each other out because there's no up-down motion, okay? So the applied force pushing to the right, force applied is going to be 20 newtons. The force of friction is 15.5 newtons. Okay, so your force applied to the right is 20. Friction force is 15.5 to the left. So 20 minus 15.5 equals 4.5 newtons to the right. Or I would also accept that answer as long as you put this there. If you just put this, that's not correct. That's a wrong answer. If you put the plus in, that's when it becomes the correct answer because you're telling me that it is moving to the right by putting the plus sign in. So either this answer or this answer with the plus sign. All right, so that's number 2. P.S. I love my new board. Just saying. All right. A car accelerates forward on a flat road. Car accelerates forward on a flat road. On a flat road. So what do you know? Force is working on it. It's on the ground. Force of gravity. Force normal. Cancel each other out, right? Because it's accelerating forward. It's not accelerating up or down, moving up or moving down. It's accelerating forward, which means it's accelerating to the right. So this would be your force applied, which is 2,000 newtons. Okay? So if something's moving to the right, what has to be going against it moving to the left when it's on the ground or on a flat road? It's got to be the force of friction, okay? And notice that this arrow, much longer because of this is a much higher magnitude than this is. These two arrows are about the same length because they should be because they cancel each other out, okay? So you can see force applied, much greater, much longer arrow because it's got a higher magnitude than the force of friction. All right. So now what's your net force? Your net force is, these cancel, so that's 0. 2,000 minus 500. So it's 1,500 newtons to the right. Or plus 1,500 newtons. I would take either one of those answers, but you have to put the plus sign in because that determines your direction and it tells me that you know it's moving to the right. All right, so that's the car accelerating on a flat road. All right, this one. A person hangs motionless from a vertical rope. Okay? So there's no left-right movement. We just have up and down. So we just have up and down. Okay? So your force of gravity is what? 600 newtons. Key word in the problem, motionless. So if it's motionless, what does the net force have to equal? The net force has to equal 0. So there's one rope, force of tension. If the net force has to be 0 because it's motionless, what does the force of tension have to be? It has to match 600 newtons. So your net force equals 0 newtons. Why? Because it's motionless. Because object is motionless. Okay? Does that make sense? Hopefully it does. All right, now the next one is gonna kind of blow your mind a little bit because it's completely opposite of what we just did. All right. So we're talking about the sled going down a frictionless hill. Okay. So you have your sled. The force of gravity is 100 newtons. Your force normal is also 100 newtons. If something is in motion down a frictionless hill, doesn't matter if it's icy, doesn't matter if it's anything. If something is in motion down a hill and there's no friction and there's nothing applied to it, what's it going to continue to do? As long as it's a hill and as long as there's no friction, that object is going to continue to move in the same direction in a straight line at the same speed. So therefore, there's no applied, there's no friction, there's no anything. The only thing you had was the weight of the sled, which is on the ground. So because it's on the ground, you got to do both gravity and normal. Well, again, it's going to be a net force of 0 newtons because it's just going to continue to move the way that it's moving because there's no force being applied to it and there's no friction that is slowing the object down. So because there is a net force of 0, it's going to continue in the direction it moves until an unbalanced force acts upon it. Okay, again, keep that in mind. That's the first law of forces. All right. So that's the the sled sliding down a frictionless icy hill. All right. Let's do the next one. A ball is dropped from rest. Ignore air resistance, which means the ball is going to be in what? Free fall. That means we only have to do one thing. When a ball is in free fall, force of gravity is the only thing working on it. So it's 5 newtons. There's no air resistance. It says ignore air resistance. So what's your net force? Your net force is, that's an S, 5 newtons down or -5 newtons. Okay? Because it ignores air resistance, it means that something is in free fall. That means there is no resistance going against it, and it's just going to go at 5. It's going to go at whatever its weight is. And that's what the net force will be. All right. So that's that one. All right. A picture frame, is suspended on a wall by 2 strings. A picture frame is suspended on the wall by 2 strings. Okay. So, what do you know? What's the automatic one you got to put in for anything? It's the force of gravity, right? And the force of gravity in this case is 10 newtons. Okay, so that's 10 newtons. The picture frame is suspended. So when you look at picture frames, are they generally swinging around, moving around? No, they are going to be suspended and they're not going to be moving. Okay, so if they're not moving, what does the force of tension have to equal? The force of tension has to equal 10 newtons, right? And because it equals 10 newtons, there's two strings. Well, what are we going to do with the two strings? We're going to draw two strings, force of tension, they have to be equal, so it would be 5 newtons and 5 newtons. And what's your net force? The net force equals 0 newtons because the picture frame is not moving, but you have to split the force of tension over both strings and it has to be an equal amount because they're the same. Questions about that? If you do, come and see me or shoot me a DM. All right, here we go. Here comes the fun one. All right, so